this as well properly so that we'll have it. Okay, it is recording. Okay, beautiful. All right, so on Friday, so Monday afternoon, we learned about bivariate data. Okay, and in this part of the topic, we've just finished linear. We've finished everything algebra related. Now we're going to bring it back to the practical side here and apply it to what we call your line of best fit. Okay, there's a reason why it's called that, because it's a line that best fits the data. Okay, so your intention today is to be able to fit a line, which means draw a line. That's what that means. When you say fit a line, draw a line of best fit, and you'll be able to use it to predict the data using values and using a linear equation. So remember, your linear equation normally look like this: y equals mx plus c. Okay, and if you look back at the previous chapters, this would all make sense. Hopefully, by the end of this tutorial, you'll be able to draw your line of best fit by eye. So basically, that's saying just draw a line to represent the data. Find the equation of a line, which is basically this equation, and then use that equation to make a prediction, whether it's interpolation or extrapolation. So interpolation meaning in the data, extrapolation meaning outside of the data. If it's interpolation, it's accurate. If it's outside, which is extrapolation, it's not accurate. Okay, so that's what we're focusing on for this topic. So if you have listened and watched all the videos that Torio has uploaded, all of this will make sense to you. Okay, in the previous lessons, we learned about graphing equations. So you remember the graph that we used, which was called a Cartesian plane, looks like this. Okay, and then for example, you may have had a line that went like this. So you had to draw that line. This is how you graph a line. So you've got your Cartesian plane, then you draw your lines. Okay, this is what we learned in the previous lesson before this one. You're going to be using this skill, okay, to figure out equations of a line and making a prediction. All right, so if you haven't already, I encourage you to watch the previous lessons. All right, so a line of best fit is basically used to, the best way you can explain this is it represents the data in a scatter plot. So it's basically a line that represents that data. Okay, the line is drawn by eye or by hand, and it goes through the dots. So the line of best fit is useful for making predictions. That's what the line of best fit is for. So here's an example. You've got your graph. The line of best fit is the one in blue. Okay, this guy right here. And you can see that it goes through the dots. Okay, that's a really good line of best fit. So you basically, what will happen is you'll get a scatter plot. Might look like this. And to draw a line of best fit, you just got to draw a line through it. Like that. All right? So that's an example of a really good line of best fit. Now, there are examples of bad lines of best fit. So this is bad, as you can see here. Ramia, do you remember why this is bad? It's not in line with the dots. Good. Eamon, why is this one bad? Have a look. Is it going through the dots? Okay, you're shaking your head, which looks like a no, so it's not. Regan, why is this a bad line? Have a think. Compare it. This is going through the dots. What about this one? It's a bit too high, isn't it? Yes, it's not going through the dots, so that's a bad line of best fit. You've got to make sure your line goes through the data like that. Okay, that's a good line of best fit. That's why it's called best fit. Okay, so let's make predictions. So the reason why we have the line is you're trying to make a prediction of the data. So you're actually using the line to figure out certain bits. So let's say, for example, what is the value of y if x equals 2? And what is the value of x if y equals 10? Okay, so remember, if you're looking at your axes, this is your x, this is your y. Okay, always. On the x is the horizontal, on the y is the vertical. So we're going to try and make some predictions. So let's start with the first one. What is the value of y if x equals 2? So if you're looking at x here, where is x where it equals 2? Well, it's down here. Okay, x equals 2 is going to be here. Follow the line to see where it hits. Follow up the graph to see where it hits on the line, and you can see it hits here. And then from there, you make your way to the y-axis right there. So that means the value of y is going to be 5 if x is 2. So the coordinate for that, looking right here. coordinate is 2, 5. That's 2, 5 right there. That means if x is 2, y must be 5. Okay, that's what that's saying. Let's try the other one. What's x if y equals 10? So now you're looking at y equals 10. So y would be on the y-axis here. Right there. Follow the line. So go to the line, line it up right there. And you can see that if y is 10, x must equal 6 down here. Alright, so that means the coordinate for it is 6, 10, which is this. That's 6, 10, right there, that dot. Okay, that's what that's referring to. So if y equals 10, x must equal 6. Okay, now using the prediction. So this is where I think a lot of you guys are copying these notes down, which I would recommend that you do because you'll be using it a lot for this topic or when you do your SAC. Okay, so Samara and Raquel, hope you're listening, yeah? Writing notes down. So for the graph below, find the equation. We're going to find the equation now for that line. Okay, every line has an equation. Every single line. So this guy must have some sort of equation, this line. And this is how we do it. So what you need to do is remember back in the previous chapter for 1G, we learnt about finding the gradient, which is this formula. So you need to first start by finding the gradient. Okay, to find the gradient, okay, we use the formula y2 minus y1 divided by x2 minus x1. Gradient in my formula is this. Remember, y equals mx plus c. That's this guy, the gradient, m. All right, so on this graph, what you need to do is find any 2 points on the line. Doesn't matter which ones they are, as long as it's on the line. It has to be on the line. So as you can see, you can't use any of the red points, or you can actually, but it's probably better to use the black points because they're all on the line. And I put them there myself. Okay, so any 2 points on the line. You can use 2, 5. You can use 4, 7.5. That's what this is here. You can use 6, 10. You can use 8, 12.5 or 10, 15. Any 2 points. The best thing to do is just pick any easy points. And when I say easy, make them really obvious. So the really obvious ones here, I chose 2, 5 and 6, 10 because I already know the exact spots for them. I could use this, but I don't know what this value is exactly. Okay, you could use that. You could also use this, but again, you don't know what this value is. So it's better to use 2 points on a line that you know the exact points. So in this case, 2, 5 and 6, 10. All right, that's what we're using. Right, so now we're going to find the equation. Oh, sorry, yep. Copy it down. We're going to find the equation. Remember, by the way, on any equation, y equals mx plus c, there's 2 things you're looking for. You're looking for the gradient, which is this, and you're looking for the y-intercept, which is this.
Are we drawing this graph or this?
For what do you mean?
So we're doing the graph or we're just writing the line?
We're trying to find the formula, which is this guy. Okay, and it's for this graph.
So do we need to copy the graph?
Not necessarily, no, you don't have to. But I just want you to at least copy down the 2 points. Those are the 2 things you need to use. You need 2 points. So the next part is what I want you to copy down as well on how to find the equation. Because I think a lot of you guys didn't watch the video for this. So this is your chance now. Alright, I'm going to go to the next part. We ready? Okay, I'm going to go. Here we go. Alright, so we've got our 2 points. Good. Remember, my formula, my equation is y equals mx plus c. There's 2 things I'm looking for, the gradient and that y-intercept. You've got to find both of them. And this is how you do it. So to find the gradient, remember, that formula that we had, this guy here, y2 minus y1 divided by x2 minus x1. Start off by labeling your points. Always call it x1, y1, x2, y2. Don't ever go, so if I get rid of this, don't ever go x1, y2, x2, y1. Don't do that. Okay, it's either x1, y1, x2, y2. It actually doesn't matter if you go x2, y2 or x1, y1. Okay, as long as you've grouped them together as x1, y1, x2, y2. Okay, that will work. So on my formula, using it there, I'm just going to substitute y2 and y1, so that's this guy and this guy, into my formula. So that will be 10 minus 5 for the top, right, 10 minus 5, and then the bottom is x2 minus x1. So looking at my formula, x2 is 6, x1 is 2, it's going to be 6 minus 2. Working that out. Okay. I'm going to ask some of you guys. What's 10 minus 5?
5.
And then what's 6 minus 2?
4.
4. So the answer is 5 over 4, which you can use as a decimal as well, 1.25. So my gradient so far is 1.25. All right, easy. Now the next part is a little bit trickier, but this goes back to the lessons we learned in chapter 1F and 1G when you were solving your equations. Okay, so this is when you need to understand how to solve equations. So for the y-intercept, you're looking for C on your formula, which is this. So to do that, all you have to do, get your formula, okay, and you're going to change a few things here. You know what your gradient is, okay, which is good, but now you need to just pick any of the 2 points that we have. So you can use these points, or you can use these points. Remember, that's x, that's y. On my formula, all you have to change is the gradient, and then get one of the x and y points here to change x and to change y. So pick any of them. I'm going to use 2, 5 because they're really small numbers, and that's good. So I'm going to change m and then x and y, those three. And see how m is 1.25, which is what I got here. X is 2, so I use this point, and y was 5. So this one here is this one. I just changed it. That's all it is. And then from there, you're just going to solve C. Figure out what C is. So evaluate it. Again, if you've watched the videos, actually I might ask some of you guys here. Regan, I've been working with you on this. What's the first thing we need to do here? What should I evaluate first? Right there. I'm squaring it for you. What's this? You have to evaluate this first, right? Right, so that means 1.25 times 2. Put that together. So you get 2.5. Okay, what's next? What should I do next, Regan? You know this. I want to make C by itself, so what do I do? What am I getting rid of? Yep, the 2.5. It's plus 2.5. So if I bring it to the other side, it becomes good minus. So that means 5 minus 2.5 equals 2.5. There's your y-intercept. So putting all of this together, okay, put it all together. So I've got my formula. I want to change m and c on it. On my formula, I'm only changing those two letters, the gradient, the y-intercept. And there's my formula. Okay, so y equals 1.25x plus 2.5. That's it. That's how you find the formula for your line. I know it takes a bit of time, but once you actually get this down pat, actually this part, everything else is pretty easy. I think this is the hardest part, just this, which is what most kids find a bit difficult. Okay, so make sure you've got this because you're going to be doing it a lot in your SACs. All right, so now that we've got our equation, I see some of you guys are writing it. Now we can make predictions using this equation. So we're going to use this guy to make a prediction. Okay, and essentially what you're doing to make a prediction is you're just changing either x or you're changing y. That's it. And then you're finding out the value. So if I use my equation, which is this one, I'm going to basically just substitute the values to find the unknown. So what is y if x equals 4? So let's start with that. What's y if x equals 4? All I'm changing in my equation is x. I'm going to change that to 4. So that becomes y equals 1.25 times 4, and then you just evaluate it. You can use your calculator, you can use your head if you're smart enough, but the answer is 7.5. Okay, and then the coordinate for that should be 4, 7.5. If it asks you for the coordinate. Okay, so 4, 7.5. Next one, what is x if y equals 12.5? So now instead of changing x, I'm going to change y to 12.5. Okay, so y is now 12.5. So 12.5 equals 1.25x plus 2.5. Okay, does anyone remember how to solve this? What if you get a question like this? What should we get rid of first? Anyone know? What should I get rid of? This is 1.25x plus 2.5. What should I get rid of? This guy. Oh, this one here. Okay, so isolate x. Remember that. So if this is plus 2.5, if I bring it on the other side, it becomes minus 2.5. So 12.5 minus 2.5 equals 10 so far. And And then from there, I'm isolating the x. So I have to move this 1.25. It is multiply by, bring it on the other side, it becomes divide. Therefore, the value is 8. So the coordinate is 8, 1.25. Oops, sorry, 8, 12.5. My bad. Alright, so there is the answers for that. So for making your predictions using the equation. Essentially what you're doing is you're just changing x or y for the prediction part. That's really easy. And then solving it. If you have forgotten how to solve, I really recommend you go back to the videos for, I think it was 1F and 1G. Okay, those are the ones that will help you with the solving. Or was it E? I can't remember. Alright, let's go into the last part of these notes. So we're going to look at predictions with interpolation and extrapolation. Okay, when you're making a prediction, the accuracy is going to depend whether you're making a prediction within the range or outside of the range. So these are the two things you've got to think about. If you make a prediction, is it within the data or is it outside of the data? Okay. If you make a prediction within the range, it's going to be reliable because it's in the data that you already know. And if it's reliable, it's going to be called interpolation. If it's within the data. That's what interpolation means. Predictions within the range. That's what that means. If you make a prediction outside the range, okay, it's going to be unreliable because it's outside of what you actually know. And if it's outside, it's called extrapolation. So if you're extrapolating, it's a prediction outside of that range. So remember that. Interpolation in, extrapolation is out. Interpolation reliable, extrapolation not reliable. Right, so remember those two things. All right. We'll go to the next part. This will all be, okay, I'll give you a second. All right, so all of this, remember, available on OneNote and on Teams. I will record it, so you will have it with you and you'll be able to use it, okay? And again, all of this stuff, everything we've done so far, just all relates together. So, yeah, hopefully it makes sense, yes?
Can you write back a slide just quickly? Thank you.
Okay. Anyone have questions so far that I can answer? No questions. No, have you got a question? Nothing? No other questions? Okay, we're getting it so far. How to make the formulas, how to make the line of best fit or find the equation of the line. Right? Not that hard, I think. But I'm happy to explain it again if you need it. Okay, let's move on to the last bit. People still copying. It's all right, we're nearly there. Nearly there. All right. Also, with the predictions, just remember that you're obviously it's going to be with a scatter plot, okay, and you're going to have a line of best fit in there. So the predictions, again, you're focusing on the range of the data, so where the data is, and how that will sort of determine whether you're accurate with your predictions or inaccurate, okay. And last lesson, I actually went through this with you guys. With the box. Right, so all done, Miss Kermie? Nearly there? All right, I'm going to go ahead and I'll go back to this for you to copy, okay? Sorry. All right, now we're going to make a prediction with the data that we have. So we've been looking at this graph this whole time. In the graph below, you can see where the range of the data is by examining or imagining, a rectangular box. So this rectangular box, okay, will sort of determine your range. Anything outside of the box, okay, is going to be considered extrapolation. Anything within the box is interpolation. So let's say, for example, Huckton makes a prediction. What's the value of y if x was 12? That would be here. Okay, so Huckton, tell me, is this interpolation or extrapolation?
Interpolation.
I just made a prediction outside the box.
Oh, I thought you were talking about like the rest of it.
No, this prediction I made.
The other one.
Why is it extra?
Because it's not in the box.
Not in the box. It's not a accurate, or it's not a within the range. Okay. What about what is the value of y if x was 4? So right here, is this interpolation or extrapolation? Inter. Anybody?
Oh.
Inter, because it's in the range. It's in the box.
It's like that in the box.
So let's try and see if this makes sense. what is the value of x? If x is 6, what would y equal to? So if x was 6, where is x? Right here. 6 is over here, so that means my dot should be there somewhere. Right? So that dot right there, where is it? Is it in the box or outside the box? It's in the box, okay? And you can see that the value of y would be 10. So is this interpolation or extrapolation? It would be interpolation because it's in the range. It's in the data. And you're using that line, again, to make that prediction. Okay, using that line of best fit. Let's try another one. What if y was 17.5? Okay, 17.5 would be here. So if you follow that, it hits the line over here. Okay, so again, following that right there, the value of x would be 12, which is great, but is that an accurate prediction? It's outside the box, so it's not accurate. Okay, therefore it's extrapolation or extrapolating because it's not in the box, it's not reliable. Okay, so those are two things you need to know. Interpolation, reliable within the range. Extrapolation, not reliable outside the range. All right, I might actually skip this one and just let you guys work from now, okay? Or do you just want me to go through it? I might skip it, all right. Okay, look at me, you may copy that down. Give me a sec while I finish the recording. Okay, cool. All right, so here's an exact example. Guido wants to know if there's some sort of connection. Remember, that's what correlation means. Connection between the age of a person and the amount of hours they spend watching TikTok. Right? Because there probably is. Okay, and he records his findings in the table below. So here's a table of all the data. Right, now you probably all have forgotten a little bit of this, but remember how to make a scatter plot. Okay, scatter plot, you've got your x and y, and then you just got a bunch of dots. Okay, that's a scatter plot. Second part of that question is make a line of best fit. Cool, not too bad. Third part of that question, part C, use your line to predict the number of hours a day an 18-year-old person would be watching TikTok videos. Is this predicting a interpolating or an extrapolating type of prediction? And then part D is based on the line of best fit. What is the predicted number of hours a day that a 45-year-old person will be watching TikTok videos? So your parents, would they be watching TikTok videos? Interesting. All right. Part 1, make a scatter plot. So for this, you want to make sure that your scatter plot includes at least all of the important information. So label your scatter plot, both axes, and make sure you've got proper numbers for your scatter plot. Okay, that fit all of this. So for example, here for age, okay, my age range is from 11 all the way to 42. So you want to make sure you've included at least everything from 11 to 42. And then for your hours, okay, here I've got everything from 4.5 all the way to 0. So make sure you've included all of those values. From there, plot it. There's the plot. Nice and easy. Do we know how to plot points? Yeah, it's not that hard. Yeah. All right, plot your points. And then you can say, if you want to define or you want to talk about the correlation, does anybody remember that? Strength, direction. What are the three strengths that you have? You've got weak, moderate, strong. Can you explain what they all mean?
Like how fast-paced they are?
Yeah, so if they're weak, that means they're quite spaced apart. If it's moderate, they're a little bit closer. If it's strong, they're pretty close and they almost make a straight line. What would you consider this to be? Probably moderate, but I did write strong here. Depends sometimes on how you read it, but I would say somewhere between moderate and strong. And which direction is it? Is it positive or is it negative? Negative. It's going down, so it must be negative. Cool. So let's fit a line of best fit. Anyone can do this. Okay, but you all might have slightly different lines when you draw your lines, but that's okay as long as it represents the data well. So there's my line. You don't want to draw a line that looks like this, yeah? Don't do that. Don't do that. Don't do that. Okay, make sure it fits the data. Easy. Now we make a prediction. Okay, so using your line, predict the number of hours a day an 18-year-old person will be watching TikTok. So if they're 18 years old, that would be about here somewhere. Okay, follow that up there. And then from there, put your line all the way here. Now, again, your prediction might be slightly different here, but in this case, if they were 18, they'd be watching about 4.3 hours of TikTok per day, which is a lot of hours. How many hours do you guys spend on TikTok? Don't lie.
Like 5.
5? Would you say that this graph is accurate?
Not really.
Really? I would say that the younger
I was
you...
hitting a bit low.
Really? So you're saying that the younger... Actually, this should be like this then. Technically. Well, this is my prediction. I thought you guys would watch about 4 or 5 hours of TikTok per day. I am mistaken. Actually, none of you guys are 18 though. So how old is... Who's 16 here? So you guys would be like about here. Is that correct? That's like maybe... that's under 4, so that's like 4.7 hours. Do you guys spend that long on TikTok? Wow. Yeah, no, maybe. Well, you're not like Michelle Kim, who has no TikTok. But that's cool. That's cool. So if you think about the prediction, is it interpolation or extrapolation? Is it reliable or not reliable?
Reliable.
Why is it reliable?
Because in the box.
In the box, in the range right here. So it's interpolation.
So, was that dot there before, or did you put
I put that there.
Oh, okay.
So that's a new dot. So it is interpolation. Reliable. All right. So let's think about this. Based on the line of best fit, what is the predicted number of hours a day? A 45-year-old person will be watching TikTok videos. Okay, so think about your parents. Do your parents watch TikTok? Oh my
Yeah.
gosh, no way. Really?
Yeah.
Wow. That's crazy. Yeah, that's
You
crazy.
can see some of the TikTok on Facebook.
Right. Well, okay, that would count, I guess. But I mean, this is data based on Guido's friends. But anyway, 45-year-old person. So let's have a think, guys. Where would 45 be here in terms of age?
Outside the box.
Good. So, but it would be here, yeah, on the number line. This is 45. So if they're a 45-year-old, if you try to think about where the line's going to go, about here, is that accurate? Have a think. If you're 45, you're going to be spending negative hours watching TikTok. Does that make sense? Not really. Okay, so 45, if you think about it, negative 1 hours, doesn't really make sense. It would be an unreliable prediction because it's outside that range. Also, as I drew here, it's possibly going to be here somewhere. Okay, and also it's impossible for anybody to be watching negative hours. Doesn't make sense. Cool. So that's what interpolating, extrapolating, line of best fit, finding the equation, making predictions, all of that is. So as a recap, remember, line of best fit, okay, has to fit the data well. And obviously it's used for making predictions. You can use the data as well. You can use plot points, finding 2 points, and then finding the equation to find the equation to make a prediction. And then remember what interpolating and extrapolating means. Those are probably the main things we need to take away from this. That's it. Cool. Alrighty.